Welcome to Excel 2010 statistics video number 18. Hey, if you want to download this workbook, Business 210 Excel 2010 Chapter 2, click on the link below the video. In this video, we got to talk about histogram, shape, and skew. Now, here's some different histograms. Each one has a slightly different shape. This one is a sample taken from test scores. So for this test, it looks like most people got between 75 and 90. There was some 90s to 100, 60 to 65, and then there was a few really low scores. Now, this kind of histogram, when we talk about skew, has a particular name. This is skewed to the left. This is to the left. It means there's a couple of really small values. Now, it says skew to the left or negative. You could call this negative skew. And here's the reason why. If you're calculating the average, right? Averages add up all the scores, divide by the count, right? Well, most all of the values are right in here, right? So you'd expect an average right in here somewhere. Right here. But no way. Anytime you have one really small value that pulls the average, the calculation called mean, down. Now, we'll actually do skew calculation, average calculations in Chapter 3 doing our numerical measures. But this is just a picture of a histogram. And when you have a shape like this, it's called skewed to the left or negative. Another one, and if I hit if another shape for histograms is called skew to the right or positive. Now look, most of the values are right in this range right here, but boom, 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 there's one really big value up here, right? Skew to the right, because there's a big value. Again, if you were to calculate the average, this $1 million house would pull the average or mean calculation up. Now, these are house prices, and that sort of makes sense, right? 150 to 450,000 for this particular area. That's where most of the house prices are. But oh, there's a few really expensive houses up on this end. So this is called skewed to the right or positive. Here's a distribution that sort of looks bell-shaped. Human height is one set of population data that tends to be bell-shaped, right? Because most people are 5 to 6 feet, right? And then there's some 4 to 5 feet, some 6 to 7. But way up here, you're not going to get very many. Way down here, you're not going to get very many. Another possible histogram shape is called bimodal. Now, we'll talk about modes in Chapter 3 when we do numerical message. Mode just means, hey, which one occurs the most frequently. Now, notice there's a really tall one here and a really tall one here. So it's as if there's two peaks, bimodal. Now, and this is test scores, right? This happens with test scores sometimes. Now, I have the data randomized. So if you hit the F9 key, we can get different samples here. Again, this is for tests, and still we took a different sample, and still it's skewed to the left because there's a really small value. Here's house prices, skewed to the right because there's a couple of really big values. Human height still kind of looks like a bell shape. And this test sample is still bimodal. So if I keep hitting F9, you can see we keep getting different distributions, but they all sort of have the same shape. Now, shape for histograms is important. If you get lots and lots of samples over time that have the same shape, you can then say, well, the population distribution tends to be bell-shaped. It tends to be skewed to the left. And in later chapters, chapters 5 to 9, we're going to be talking nothing but probability distributions, which will be based on the kind of shape we see in our histogram. Now, let's go over to, I'm on the sheet skew this whole time. I should have said that earlier. Now I'm going to go to 21.2. Again, this is test scores. here we have skew to the left. Another example would be death rates, right? So if it said 0 to 15 years, 15 to 30, all the way up here, right? Very few people will tend to be dying in the early years, whereas more people will be dying in the upper years, 60 to 70 or whatever it is. Let's go to the sheet 21.3. This is the bell-shaped one. Other possible populations that are bell-shaped, human weight and height, cereal box weight. So later we'll have some examples in this class of a machine filling weights, right? So you can imagine the machine is just filling thousands of boxes of cereal, right? Most all of them are going to be right where if this said 10 grams or 10 ounces or whatever, most all the boxes are going to be right in the middle. But a few will be this direction, a few will be this direction. So cereal box weight, or bags of lettuce or spinach at the supermarket. Those all tend to have a bell-shaped distribution. SAT scores also. Let's go to 21.4. Now, this distribution is skewed to the right. Positive. Now, for house prices, that makes sense. But think about this. What about salaries? Most of the people make salaries in the low range, and then there's a few of those executives that have scammed the system and for some reason get paid $15 million. Or investment bankers get paid $500 million. During the financial crisis, some of the guys that ran the companies into the ground, got paid hundreds of millions of dollars. So there's a few really big values, but most of the rest of us just are making salaries down in the lower range. So that's another example of a population of data that has a skew to the right. Data entry errors, manufacturing defects. So imagine defect 0, 1, 2, 3. Most of the counts are going to be in the 0, 1, 2, 3. There's in a manufacturing process, when you're looking at a particular product or you're looking at a particular person in data entry errors for an invoice or something, there's probably not going to be 10 or 20, right? That's another example of a skew that's to the right. And then the last sheet is 21.5. Oh, this is just purchases, right? Purchases in a department store. Our sample we have from a Boomerang website, right? Most of the purchases are going to be in the very low range. Very few people, at a department store, right? They're going and buying socks and shoes and things like that, $100 or something like that. Well, every once in a while you get someone who spends thousands of dollars to buy all their furniture or all their their stove, their oven, etc. This is highly skewed to the right. A few really big values are pulling up the average. All right, one last really cool kind of example: histograms and shape. Now, what I've done here is I simulated samples: test 1, test 2, test 3, test 4. And what I want to do is, and then I did a massive frequency distribution up here. I actually used the frequency function. And here are the counts. So test 1, sample 1, most of the people got with an upper limit of 70. So from 60 to 70, 22 people got that score on this test. In this sample here, 31 people got between 70 and 80. In this sample here, looks like the biggest, tallest one, that's the mode, was between 60 and 70. So what I did is I created all these frequency distributions counting in these categories. And I want to create a bunch of little histograms and see from all these samples whether the shapes are kind of similar. Because again, in this class and later chapters, we're going to be doing probability distributions, which are based on what is the shape of the population. All right. There's a cool new feature in Excel 2010, insert Sparklines. And Sparklines are specifically built, they're cell charts. And they're specifically built when you have a bunch of data like this. So watch this. It's so easy. You highlight it. You go up to, these are the cells where the charts are going to go. You go up to Sparkline column. And I'm going to say the data range. And it will know right here, it will know for this cell, take that data. For this cell, take that data. All right? And I click OK. All right. Now, I'm going to do something totally ridiculous. It's not required for this class, but I want a label here. I want it to say whatever the maximum value is, because I'm looking at this and there's no scale, right? Most of our charts have labels on the axes and numbers at the top. Now, cell charts are really not supposed to. They're just supposed to be a quick visual imprint. And in fact, you could see it looks like there's always one tall one, so it's got a single mode. It seems like the tall one's always on the upper side, right? So if these are test scores, that makes sense, because there's always a really small one for this particular sample that's always pulling it down. So this is skewed to the left. But it also sort of looks like it's always got a little bell shape right there with a skew to the left. Now, I want to make a label here. If we did equals max, I could say the max of all of these, right? Because if I have all of these charts and I want the max at the top and a 0 at the bottom, the maximum any of these could be would be whatever the max is in here, 24. Now, what I really want is I want a 24 right at the top right there and a 0 down here. Right? Remember when we made charts, we had a bunch of numbers, right? But all I want is the biggest number here and a 0 at the bottom. Now, we're going to make a text formula here. Now, I could do this. Ampersand, that's our join symbol to create text. Double quotes and like space, space, end double quote, ampersand 0. Right? So all I've done is I've combined whatever the max is, a couple spaces, and a 0. Now, that's not going to work because I want the 29 up here and the 0 down here. I'm going to come up and on the home ribbon use wrap text. Well, that didn't do anything either. Well, OK, we're going to do something pretty weird here. There is a character, and I'm just going to show you here. There is something we can put into this formula. There's something called the character function that will actually add an enter, right? Because what we want is we want the 29 up here and then enter, enter, 0. So there's something called the character function. And I'm actually going to just delete it. I have my max and then an ampersand. And I'm going to use the character function. And the character function with the number 10, I'm going to temporarily, because that's hard to see, I'm going to drag this to the side. The ampersand and character function. The character function, actually, there's numbers 1 to 255, because in computers there's something called ASCII characters, and there's 255 of them. For example, I think 65 is the small letter A. I think that's it. B would be 66. Character 10 just happens to be a hard return. And I want 2 of them. So watch this. I'm going to say max, ampersand character, and then ampersand 0. Now, that works fine, because I have in my formula a 31, enter, enter, 0. Now, also, if you don't have wrap text turned on, it just, those enter, enter won't show up. So you have to do that formula, right? That totally weird text formula and wrap text. Now, check this out. I have these the data randomized. So when I hit F9, this little label changes here. Now, for the class, I'm never going to test you on that. But that's just too cool of a little trick not to show for these cool new feature, Sparklines. All right, but the point of this video is what? If we have over many samples from our population, a tendency for the distribution to always look a certain way, later in this class, when we do probability distributions, we will then be able to say, OK, we can use this probability distribution. So this one clearly looks like it's got tends to have a bell shape. and it tends to be skewed to the left. All right, so we have talked about histogram shape. We talked about skew and even a little bit about sparklines and a bizarre little text formula. OK, we'll see you next video.